In this video, we'll be looking at the fly-by-wire system. We'll be looking at what it is, how it works, the advantages and disadvantages, and its redundancies. Fly-by-wire is the term used to describe the flight control system, which uses the onboard flight computer to process the flight control inputs made by the pilot or autopilot and send the corresponding electrical signals to the flight control surface actuators. This system removes the classic system, which involved using steel cables and pulleys connected to the yoke to manually control the flight control surfaces. The traditional system is still commonly found in general aviation aircraft, such as our Cessnas. When the pilot moves the yoke from left to right or pulls or pushes it, the pulleys and cables move their respective flight control surfaces. However, this type of flight control system is not only found in general aviation aircraft, but also airliners, with the Airbus A300 using a steel cable and pulley system, as well as the Boeing 737 and 747. And fun fact, the 747 features 61 meters of cable running from the cockpit to the tail. Using the Airbus A320 as an example, the fly-by-wire system works by the pilot telling the flight control unit what they like to do. When a pilot moves their side stick, they are moving mechanical levers and dampers which sit below the side stick. This movement is converted into a digital code. The flight control computer then sends this digital code to the flight control surface actuators. Once the code is received, the actuators will action the request made by the pilot. If we wanted to make a left-hand turn on the A320, this movement on the side stick would be converted into a digital signal. This digital signal will run by a wire to a set of 7 flight control computers. The first computer is the ELAC-1 elevator and aileron computer. There is also an ELAC-2 which acts as a backup to ELAC-1. ELAC-1 will receive and check the digital signal before sending it to the flight control surfaces. From ELAC, our right turn digital signal gets sent through a wire to one of the hydraulic actuators on the right and left wing ailerons, where the digital signal is turned into a mechanical force, which will move the left-hand aileron up and the right-hand aileron down. When doing a turn in an aircraft that uses a classic cable and pulley control system, we will lose altitude and the ball on the turn and slip coordinator will be out of center due to aerodynamic forces. In a fly-by-wire system aircraft, the flight control computer will send information to the rudder and elevator to correct for the aerodynamic forces to ensure that the plane is only doing what it is intended to do. When doing the turn, the digital signal is also sent to the SEC 1, 2, or 3, the spoiler elevator computer, which will deploy the spoilers to counteract the yaw and the elevator to counteract the descent. The FAC 1 or 2 flight augmentation computer keeps the slip indicator centered by applying the required rudder inputs. It also applies a little thrust to maintain speed. However, this is not an autopilot system. This system assists the pilot in flying a controlled turn. There are many advantages to the fly-by-wire system. Firstly, weight saving. Because we aren't carrying the large steel pulleys or cables, we are saving a significant amount of weight. We are also reducing the maintenance costs because we do not have to inspect or replace these cables anymore. Fly-by-wire is a far safer flight control system. Not only does it reduce the workload of pilots, it also means that a pilot can't stall, overspeed, spin, or overbank an aircraft because every input made by the pilot is checked by the flight control computer. Because it is checked before being sent to the flight control services, if it senses an unsafe action, it will override and ensure that the aircraft remains safe. This is called normal law by Airbus. Jacques Toit, Airbus's head of flight control, states that the plane's behavior, whether an A320 or A380, basically feel the same, apart from the inertia. This means that pilot training can be minimized. There are some disadvantages, however, to the fly-by-wire system. One, they are more expensive aircraft. Secondly, they are more complicated to manufacture and learn. And thirdly, there's no force feedback, meaning that flying the aircraft can feel artificial. Fly-by-wire's reliance on electrical power demands high levels of redundancy. For power, the main sources are the engine's generators, and if there is an auxiliary power unit, it will also act as a generator. Then there will be 2 more batteries aboard. In the very unlikely case that all these sources fail, there's a final backup, the ram air turbine, which drops from underneath the aircraft into the slipstream to drive its generator. The aircraft is full of redundancies to ensure safety, so there are at least 2 actuators for each of the ailerons, elevators, rudder, flaps, spoilers, and trim systems. Same thing for the engine and hydraulic control systems. Position switches are installed so that information about the control deflection and position can be measured and sent back to the flight computers. At least 2 pedostatic, angle of attack, and air data probes are on the airplane, as well as 2 or more attitude and heading reference systems, which also feed their measurements into the flight computers. These are the hearts of the fly-by-wire system, and there are at least 2 of them. Some fly-by-wire aircraft have 4. The A380 was the first plane that could keep flying safely after all hydraulic means have failed, using a system known as power-by-wire. Thank you for watching.